In this video, we're going to take a look at using trigonometry to find a missing angle of a right triangle. You're going to find that these steps are really similar to when we find missing sides of right triangle. It's just the end that is different. So here's our problem. And our first step is to go ahead and label our sides, hypotenuse, opposite, and adjacent. If you are unsure how to do this, you need to watch my Intro to Trig video. Alright, there's our hypotenuse. Across from the x is our opposite side, leaving us our adjacent side on the bottom with the 17. Alright, second step, that just makes it a little easier to understand which trig function we're going to use. You can cross out the unneeded side. In this case, that would be our hypotenuse. And now we are ready to use the two sides that we have left to match up with so, ka, TOA. This one we have O and A, so that means we're going to use TOA. Our fourth step is to go ahead and write our equation, and that's going to be tangent of x equals 12 over 17. Now is where it gets different than finding sides. Now we can just take this and write the exact answer, but it's using the inverse to write the answer. So x is equal to the inverse tangent of 12 over 17. Now you can also find the exact degrees on your calculator. And when you do that, you get 35.218 degrees. And now we'll take a look at how do you use the calculator to do that. If you have a Texas Instrument that looks similar to this with multiple lines, finding the inverse tangent can be pretty straightforward. You need the tangent -1 right above the tangent button. So you're going to hit second inverse tangent, and then you can just put in 12 divided by 17, hit your enter, and there's your answer. Goes straight to it. Now, another option here is if you don't want to go 12 divided by 17, you can make it a fraction using this fraction button right there, the A, B over C. Let's take a look. It gives you the same answer. Let's take a look at how that works. So I go second tangent, and then I hit 12, hit the fraction button, 17, and that does the same exact thing because it's dividing. So your choice on what button you want to use there. All right, if you have a Casio calculator, there's actually a couple different ways you can get this problem wrong. So if I do just like I worked on the TI, I hit shift tangent, I go 12 divided by 17 and equals, I get 5. That's not the right answer. There's two ways you can fix this. The problem is the TI, or this Casio, did not put parentheses in for us. If I redo this and put parentheses in, second tangent, and then I put parenthesis, and now when I go 12 divided by 17, it'll do the inside parentheses and then find the inverse tangent. There's my right answer. So if you have a Casio like this, I would advise, if you don't want to mess with the parentheses, then using this fraction button is the fastest way to do it. So if we clear this, so the fastest way on this one is second tangent 12, hit the fraction button, hit 17, and there's your answer. Let's take a look at how we use the single line calculator to figure out a missing angle using the inverse tangent. So it turns out there's ways that can work with this calculator and ways that don't. So let's just jump in and try 12 divided by 17. And then we know we want inverse tangent. So notice that's above the tangent button. So we have to hit second and then inverse tangent. That is not the right answer because we know we're supposed to get 35.218 degrees. So what went wrong here? What happens with this calculator a lot is you need to use the equal sign at certain points. So if I go 12 divided by 17 and hit equals, now it's going to find the inverse tangent of that decimal. Instead, it probably just found the insert tangent of 17 on the last one. Now when we hit second tangent, there's our answer. That rounds to 35.218 degrees. All right, next problem. If you think you're ready to give this one a try on your own, go ahead and pause the video and see if you can go through the 5 steps. All right, so first step, we got to mark our triangle. So we are marking our hypotenuse. Across from the N is your opposite side, and that leaves the 47 as your adjacent. If it's helpful, cross out the side we're not using, in this case the opposite. That leaves us with A and H, which is ca. So we're going to use cosine, and our equation is cosine of N equals 47 divided by 59. And instead of trying to fraction bust and get rid of the divide by 59, we use the inverse to go directly to our exact answer. So N is equal to the inverse cosine of 47/59. And try out your calculator. Can you come up with 37.192 degrees? Time for practice problems. So you're going to want to pause the video when you see the problem and work it out, and then go ahead and hit play to check your answer. All right, first problem. Go ahead and pause your video. All right, let's check this. Mark your hypotenuse across from the right angle. Across from X, the 64 is your opposite, leaving the 67 as your adjacent. You can cross out the hypotenuse. That leaves O and A, so that's going to be TOA. You're going to be using tangent. Tangent of X equals 64 over 67, which means X is the inverse tangent of 64/67. On the calculator, you should have gotten 43.688 degrees. All right, pause your video. Try this one out. All right, did you mark your hypotenuse, which is the 31? Across from the N is your opposite side, leaving the 24 as your adjacent. We can cross out that O, leaving us with A and H, so this is ca. So we're going to use cosine. Cosine of N equals 24 over 31. That means N is exactly equal to the inverse cosine of 24/31. On a calculator, we round it to 3 decimal places and we get 39.268 degrees. Last problem. The hypotenuse is the 97. Across from the N is your opposite side with the 84, leaving the adjacent on the bottom. We can cross out the adjacent. This time we have O and H, so that is so. We're going to use sine of N equals 84 over 97. So N is the inverse sine of 84/97. And on the calculator, you should get 59.995 degrees.